So this is our X. So bedroom, like number of bedrooms. So you can see that feature 1, the center for cluster 0, feature 1, which is number of bedrooms, is actually 3.3. And then bathroom is actually 8.3. And then rooms, number of rooms is actually 8.4, and so forth. And square footage is actually 2600-ish, right? Because it's times 3, so 2600, right? So, and so forth. So you can actually pretty much like think of it as like you can plot it. You're plotting this thing in 7-dimensional space. So actually we can do something very interesting, right? So because we have the sign from these labels, right? We have array of labels, right? And then each data point gets a label. So we can actually call it labels, right? We are going to assign this, so let's just call it labels. We can say X, this is to assign, remember, a new column, right? We can say the cluster is equal to this labels. So now if you look at x.head, all right, so you see this newly appended, right, column to the end. You have a new column that's called cluster. Okay, that's great. So what we can do is we can group it by, right? Do some like quick stats. Group by our new cluster that we just got from this k-means that we just created. And now we want to look at, you know, the mean, right? So you can actually see this is pretty much the cluster center. Very, very close to the cluster center. But you can actually see the stats, right? For cluster 0, what is the mean? The average bedroom, bathroom, rooms, square footage, that, right? And then for cluster 1, these are like the average features, right? And then so forth, right? So this is actually very useful, right? And then you can, of course, look at mean, right? And then max, right? And then median, of course, median might be useful. So this is actually very interesting, right? You can actually see quickly you can create clusters, and then just using, you know, sklearn's k-mean like this, and then fit it using your feature matrix. This is how you can actually do something, you know, like this quickly, and then append this new cluster, right? The set of clusters back into your feature matrix, and then do some statistical analysis in here like this, right? So now I'm going to give you, since we don't have a lot of time left, but I'm going to give you a quick example that I just copy and pasted from Scalar. So this you can actually find from their source code. But this is to say, I'm going to use, remember the Arias dataset, the very famous Arias dataset, right? So I'm going to use that dataset to really create some clusters. So you can see that it's using k-mean, sklearn.cluster import k-means, right? It's using the same model, but it's going to be fitted differently because the data, underlying data is different. And then you can see that, you can visualize, this is a great visualization here. So you have, if it's 8 clusters, then this is how it looks like, right? Different, right? And then if it's like 3 clusters, this is how roughly it looks like, right? And then 3 clusters with like bad initiation, and then so forth, right? So like I said, initiation is something that's very important as well, like how you initiate your models. But we're going to actually talk about it later. But this is the way that you can pretty much grid search, like as opposed in terms of number of clusters, like say 8 cluster, 3 cluster, you know, or 5 clusters, right? So definitely you have to do some inspections to determine what would be the best number of clusters that you want to use. But once you have this code ready somewhere like in here, you can just pretty much write a for loop that will do, you know, look at different number of clusters, right? So let's quickly maybe do that, right? So we can actually say, you know, for I in say range of say we want to do it from up to 10, right? So from say 3 to 10, right? Then we want to do this k-means of n clusters is equal to I, right? Because that's what you're iterating through, and that fit of the same X, right? And then we'll have to drop the cluster first, I believe. And then I will, okay, so like this, and then I will say this is equal to, so I'm just putting what we have created before into a for loop so that this is how you can, to show you how you can grid search in terms of number of clusters, right? So, and then you can look at, for instance, K means the labels. So then we can print out, all these things. And then, okay, so this is how you can actually write a for loop and to do something, right? So, and there is always a score. Let me Google the score that you can use. So this is a good way of telling if the number that you're setting in here, right, in your cluster initiation here is a good number of cluster or not, right? So, yeah, so that's, you can actually, let's just maybe try this, right? So we can try it in here. Let's say we need to import it first, like we can just import it in here. Let's give me this. Okay, so let's see. Right, so remember, you can actually just do from, and then when you do that is import, right? So let's see, we can use score of your, let's see, I always go back to the documentation just because it's very, very useful. I don't typically remember everything. So yeah, it tells you like you'll have to pass your X, which is a feature, right? Like our feature matrix and labels, right? So the two things you need to pass is X and then labels, but our labels is k-means, I guess we don't need to print this. We can just call this labels, assign this as a label, is equal to that, and then we want to print out, right, this, and then we don't want to print out the score. Okay, so let's see, right? And just taking some time. Yeah, it's very slow, but this will tell you, the higher the better, definitely. Yeah, so this is the first one, right? You can actually see with 3, this is like the silhouette score for 3. And then by default, if you don't pass anything, it's going to use Euclidean distance. So, and it says it computes the mean silhouette coefficient for all samples. Okay, so the difference is, small in here, but it's going up. Okay, so let's just let it run. And then this is in our section 2.1, we talk about cluster analysis, how to use sklearn's k-means to create a simple cluster model. Thank you. And then we're going to continue to 2.2.